Okay, so this is an example of when we're going to have to multiply one of the equations to make opposite coefficients. Okay, we'll talk about what that means. First thing we need to do again is make sure that the equations are arranged so that they are so that like terms are in columns. Okay, well these are both already written in standard form, so now I'm just going to go ahead and write them one on top of each other. So I'm going to put 2x minus y equals 12, and on the bottom I'm going to have 2/3 x plus 1/6 y equals 2/3. Okay, now we need to get opposite coefficients, and again, if we have to multiply one of the equations to do that, then we can. Well, what I'm going to look for first is any signs that are opposites for those x's or y's. Okay, well, these two x's are both positives, so I don't really want to mess with those. These two y's, one is negative, one is positive, so that means I can multiply one of the equations by a positive number, okay, and they will still be opposites. So I'm going to multiply this equation here, and I need to make it the opposite of -1. Well, I can multiply this by 6, and that will make this positive 1y. Okay, so I'm going to take this whole equation, and we're going to multiply it by 6. Okay, so my first equation won't change, so I'm going to have 2x minus y equals 12. Second equation, 6 times 2/3, well that's 12 over 3, which is 4x, plus 6 times 1/6 is 1y. And again, 6 times 2/3 was 4. So what I did by multiplying this equation by 6 is now I've got opposite coefficients. Okay, this is -1, this is +1. So now they will cancel each other out or eliminate. Okay, elimination. Now we're going to add these equations together. 2 plus 4x is 6x. Negative y and positive y cancel. And 12 plus 4 is 16. Okay, now I'm going to divide by 6 on both sides and get x equals 16 over 6, which is the same as 8 over 3. Okay, so x is 8/3, 16 over 6. So that's my first value. Now again, I need to plug that into one of the original equations. Okay, plug it into one of the original equations to solve for y. Well, I'm going to plug it into this one because I don't want to deal with all these fractions. Okay, we decided that we don't like fractions for the most part, so I'm going to plug it into this equation. So I'm going to start with my 2x minus y equals 12 equation again. I'm going to plug in my x value, so it's 2 times 8 over 3 minus y equals 12. Well, 2 times 8 over 3 is 16 over 3 minus y equals 12. Now to make this a little easier to solve, because Mr. Ayers doesn't like fractions as much as the rest of you, I'm going to multiply this whole equation, multiply this whole equation by 3 to get rid of that denominator. Okay, so I'm going to take all of this times 3, and that will give me 16, because 16/3 times 3 is 16, minus 3y equals, and 12 times 3 is 36. So now if I subtract 16 from each side, I get -3y equals 36 minus 16, which is 20. And now I'm going to divide by -3. I get y equals -20 over 3. Okay, so my ordered pair, my answer should be 8/3 and -20/3. Okay, now of course we've got to check this. Okay, so these can be a pain in the butt to check, but I want you to go ahead and finish checking this, okay, and make sure it works out, which it should, okay, but I want you to show that work. Okay, and I'm going to go on to the next slide. Okay, now in this example, you can notice we're getting more and more complicated with our problems here, but this one is arranging terms first. So if I look, neither one of these these don't have terms in the same column. We got x first and y first. We got our equal sign. They're all messed up. Okay, so the best way I can tell you to do this is to probably get it into standard form. Okay, well this one's already in standard form, so I'm going to make this one in standard form. And I'm going to do that by adding 5x to each side. So that makes this 5x plus 2y equals 12. Okay, so now I got my like terms in columns. The x's are first, the y's are second, and the constants are third. So now I'm going to just rewrite them both. And then we've got 5x plus 2y equals 12. Now we need opposite coefficients again. If I look here, 3 and 5, those are both positive and not the same kind of number. 2 and 2 are both positive, but they're at least close to each other. It's the same number. So I can make them opposite coefficients by multiplying one of the equations by -1. Because if I do that, if I multiply, let's say, this top equation by -1, that will make this negative 2y, and this will be positive 2y, so they'll cancel each other out. Okay, so I'm going to go ahead and do that. I'm going to multiply this equation by -1. Oops. Okay, so I've got this equation here still, so I'll just leave it, and then that's going to give me negative 3x minus 2y equals -8. Now I can go ahead and add these together. Oops, sorry, my thing's getting off here. Oops, don't want to do that. Okay. Let me go ahead and slide this back over here. Okay, so I'm going to add these two equations together. So 5x plus negative 3x, that is 2x. 2y and negative 2y cancel, and 2x equals 12 minus 8, or 12 plus negative 8 is 4. Divide by 2, I get x equals 2. And again, I need to plug this into either one of the original equations, doesn't matter. I'm going to go ahead and plug it back in to this one right here. So I'm going to use 3x plus 2y equals 8. And I'm going to plug in 2 for x. So it's going to be 3 times 2 plus 2y equals 8. 3 times 2 is 6. Subtract 6 from each side. And I get 2y equals 2. And divide by 2 and divide by 2. And I get y is equal to 1. Okay? So my ordered pair is positive 2, positive 1. Now my job is to check it and see if it works in both equations. So again, 3x plus 2y equals 8. I want to know, does 3 times my x, which is 2, plus 2 times my y, which is 1, equal 8 or not? Well, 3 times 2 is 6, plus 2 times 1 is 2, and 8 equals 8. So it checks out for that one. Now I'm going to plug it into my other original equation, which is 2y equals 12 minus 5x. So 2y equals 12 minus 5x. And I want to know, does 2 times my y equal 12 minus 5 times my x? Well, 2 times 1 is 2, equals 12 minus 5 times 2 is 10. And it checks out. So my ordered pair of positive 2, positive 1 works for both equations. That means that that is the correct solution to my system. Okay, and we've got one last example to go through. And this is an example of when we're going to need to multiply both equations, okay? And then we'll talk about why that is here. First thing I notice is my like terms are in the correct column, so I'm going to just go ahead and rewrite this so they are one on top of the other one. Okay, now I'm going to have to multiply both equations. What I have to keep in mind here is I have to get opposite coefficients, okay? So basically what I need to do is figure out a common multiple for one of my two sets of coefficients and multiply the equation to get that common multiple. So for example, I noticed that 2 and 3, okay, a common multiple of those is 6. So I can make 6 x's with this, which is what I'm going to do, okay? But I also need to keep in mind that I have to have opposite coefficients. So one of these has to equal positive 6, and one of them has to equal negative 6. So the way I always just like to do this is I like to make my top one the positive one and my bottom one the negative one. Okay, notice these are the same sign too, so it's not going to really matter which way I do this, because I'm going to have to multiply one equation by negative, one by positive. So I'm going to keep this top equation positive, and the bottom equation I'm going to make negative. So what do I need to multiply 2 x's by to get 6 x's? Well, I'm going to take this whole equation and multiply it by positive 3. And the bottom equation, I'm going to have to multiply. Now again, I need to make them opposite coefficients, so I need to figure out how to get negative 6x out of this. It means this one's going to be positive 6x. So I need to multiply this whole equation by negative 2. Okay? Well, top equation, if I multiply it by 3, I'm going to rewrite it. I'm going to get 6x's. 3 times negative 3y's is minus 9y. And 0 times 3 is 0. Then my bottom equation, negative 2 times 3x is negative 6x. A negative 2 times a negative 2 is a positive 4y. And negative 2 times 5 is negative 10. Okay, well, now we have opposite coefficients. I can go ahead and eliminate. Okay, I'm going to eliminate my x's here, because 6x plus negative 6x is 0 x's, and negative 9 plus 4y is negative 5y, and 0 plus negative 10 is negative 10. By dividing by negative 5 on both sides, I'm going to find out that my y is equal to negative 10 divided by negative 5, which is positive 2. Okay, now I'm going to plug this into either one of the original equations to figure out what x should be equal to. Okay, again, I'm going to plug it into one of the originals up here. So I'm going to pick the 2x minus 3y variety. And 2 times x minus 3 times my y value, which I just found to be 2, should equal 0. So 2 times x minus 3 times 2 is 6. Should equal 0. So if I add 6 to both sides, I get 2x's is equal to 6. And I'm going to divide by 2 on each side to get x is equal to 3. So my ordered pair, my solution should be written as positive 3 and positive 2. Now remember, our last step is to always check that ordered pair into both equations. I want you to do that. I will be looking for that when I sign off your notes. Okay, but as of now, I'm cutting off the video. So good luck on your homework and have fun with some elimination. Okay, again, my favorite method. So don't forget to check this and then get to it when you show me your notes. I will be looking for that. All right, good luck on the homework.